What up, everybody? Going on entry 2 of our electricity and magnetism unit. Last week we did magnetism. This week we'll do electricity. And then next week, our last week, we're going to do some basic circuits. So, remember this is a review from last week that there's 3 subatomic particles. Like charges repel, opposite charges attract. And then we got conductors and insulators, which allow charge to flow or not. And this is a big idea as we go back to electricity. So this is just a little review. This isn't in your notes anywhere, so just pause for a sec here and let's review. So when electrons move, that's current. So this is electricity. So when electrons move, we get current or electricity. In order for that to happen, there has to be some type of force that causes it to move. And this is called a pushing force or voltage. So current, when electrons move, is measured in amps, or letter A is the units for that. So a typical household unit produces about 15 amps of current maximum, but then different devices don't necessarily use all that. A charger can put out about 1 amp. So voltage is, remember, the amount of pushing force that can cause current to move or electrons to move. Household outlets about 120 volts, iPod charger about 5. So these two concepts are related to a third idea called resistance. When electrons move, they bump into stuff like atoms or like atoms of copper in wire, as an example, and that causes resistance. So resistance is the opposition to current, and that's measured in ohms, and that's a Greek letter that's used to abbreviate ohms. So more resistance, the harder it is for current to flow. So if resistance goes up, current goes down, and that makes sense, right? Imagine you were a river flowing, and you built a dam. When the water hits the dam, the resistance has gone up, so the amount of water that's able to flow goes down. And that's what we see here with this relationship. So all objects are made of 3 basic things, and we should know what these are because we literally just reviewed them. But this is going back to our first unit, so now you can see a connection between our physics and our chemistry. So we have protons, neutrons, and electrons. Protons are those happy or positively charged subatomic particles. They're big. Neutrons are neutral. They have no charge. They are also big. Electrons are negative. They are small, and they move. So electrons move towards protons. This is answer to question 1 in your notes. And that is electricity. So the movement of charge is called electricity or current. So electricity is the flow of electrical charge. So remember, if you have to, pause to take notes and then continue on. So just for sake of time, I'm going to continue to move here. So objects are what we say are neutral. They have a net charge of 0. So that means protons and electrons are the same. And that's based on atomic number from the periodic table. But whenever we get a charge, whether it's positively charged atom or negatively charged atom, this is due to loss or gain of electrons. So even from the chemistry side, electrons are easily removed or added in order to create charged particles. So remember, like charges repel, opposite charges attract, and that's a force. And the more charges there are, so the more positive and negative you have, the stronger the force is. So imagine if I had 2 electrons and 2 protons, there's a attractive force between them that is, let's say size of 2, right? Since you have 2 of each. If I had 10 of each, then all of a sudden it goes to 10. 5 times more particles, 5 times more force. So one thing to note is that electricity is a movement of electrons, and there's a force to it. We call it the electrochemical force. So see how we are adding and removing electrons in order to cause charge. So major idea here is what's going to happen if I have 2 electrons next to each other. They're going to move away. If I had 2 protons, they're going to move away from each other. and if I have opposite charges, they're going to move towards each other. So charge is measured in coulombs, and Coulomb's law was discovered by Ben Franklin with the kite. That's what he discovered there. So this is a really small number. The charge is 1.6 times 10 to the negative 19, which is this number. And that's a really small number. So each electron or proton is a really small amount of charge. So it takes a lot of protons or electrons to give us a charge that we can actually measure or use to do work, because that's really what's being done. So these are things that we should know by now. We have positive and negative charges in our atoms. Negative charges like to move towards positive. The more positive we have, the more electrons want to move towards it. The force that draws them together is larger. Objects that allow current to flow are called conductors. And here's a follow-up question. What type of material do you think conductors are made out of? Based on what we knew already, it should be oftentimes metals. So all wires in your house are largely made out of copper to send current or charge through them. It conducts electricity. Objects that do not flow are called insulators. Often these are made out of rubbers or plastics. So metal wires are often wrapped in some type of insulator like rubber in order for charge to only flow one direction. A short cannot occur, and that's important. So good conductors of electricity are usually good conductors of heat and so forth. Opposite, poor are poor. So in the energy unit, we talked about potential and kinetic energy. So at the top of the hill, this object has a ton of potential. It's not moving, no kinetic. It's all transferred to kinetic at the bottom. There's no more potential when it's raised up. Well, I don't know what that was. So as potential energy in gravity decreases, it's used to do something such as move the object, create motion. And the same idea is true of charge as well. There's chemical potential energy that is used to move electrons. So how does this relate to charges? That's what we're just talking about here. What do these two negative charges want to do? They want to move away from each other, right? So there's some stored energy. If we can force them together, there's stored energy, and that as soon as we release them from having to be next to each other, causes movement, right? And if we put a positively charged atom somewhere, that's going to move towards that. So that stored energy in those electrons is called electrical potential energy. And the more negative charges we have bound up in one area, the more energy is stored up. Now your body uses this process of electrical potential energy for it to move stuff across the membrane of cells in and out as well. Which is actually kind of cool. So now you see how this relates back to biology as well. So as the charges move further and further apart, they're interacting less and less, so their potential energy decreases. So the amount of potential energy depends on the amount of particles. So if I look at a D and a AA battery here, I might have an idea of what I think is the answer to this question, but it's actually a little bit more complicated than that. So the voltage of these batteries, AA and D, is the same. Okay. Oh, what just happened here? And let's talk about voltage before we go and answer that question. Okay, so voltage, you have opposite charges separated, they want to come together. And that's called voltage measured in volts. Letter V as well. This is what makes electrons flow. So if I look at those two batteries, you might think, well, which one has more charges, right? Well, listed at the bottom, each had the same voltage. So voltage is what makes electrons move, right? And when they move, it's called current. Current's measured in amps, letter A. But in equations, you'll see it as an I. Okay? A is used for numerous other things, such as acceleration. So current is like a river of electrons flowing from one point to another. It's the path that we take. So voltage makes electrons move. And just as a river flows, it meets resistance caused by the movement of that water. And the movement is the current, right? So when you think of a river moving, oh, the current could pull you downstream. That's the movement of the water that's causing that. So when current meets resistance, you get a relationship with respect to voltage. So all batteries, and these are technically called cells. A battery is a combination of multiple cells, so multiple Ds together is what you'd consider technically a battery. But anyway, both of these have the same relative voltage. So whether it's a AA, AAA, D, or C battery, they have relative same potential energy, and that means they can do the same amount of work. Okay? The D battery, because of it has larger surface area, is simply able to push more current, which allows it to actually last longer. Even though the voltage, the chemical potential difference here is the same. So that's a confusing topic. One thing to just remember, batteries have the same voltage, so because of that, they can only do the same amount, they can do relatively the same amount of work, but the D battery can push more current. Okay, so that's the difference between these. Batteries are a topic that you should be able to understand on your own, so if you want to, you can Google that on your own. Last thing we're learning about here is resistance, which is measured in ohms. Electrons meet resistance when they travel through a wire or any device. Okay, so certain devices have more resistance. They require either larger voltage to work, or they run on a smaller current. So there's a football example here, and I don't really love that, so I'm just going to skip over it. So question 7, write Ohm's law below. Voltage is current times resistance, or voltage V is current I times R. So make sure you jot that down. Let's look at a practice problem together, and then you'll try to on your own. So relationship between voltage, current, resistance is V is IR. V is voltage in volts V. Current is I in amps, and resistance is R measured in ohms. So this is just like every other 3 variable equation that we've had this year. You're just filling out your knowns and your unknowns and solving. So if I got 10 volts, 2 ohms of resistance, I'm solving for current. So that means that I'm given V and R, and I'm solving for I. So on this side, to get I by itself, I have to divide R over. So when I do that, I get 5. 10 divided by 2 is 5 amps, and that's my final answer. So let's think about it this way. If I were to increase my resistance or make this number bigger, what would happen to the current? So instead of 10 divided by 2, say it's 10 divided by 5, my current would go down. Okay, and that's a really important relationship here. Give me 1 second. Triangles work for you. Certainly jot down this triangle. Since the V is by itself, it goes on top. I and the R by each other, they go on bottom. If it doesn't work for you, don't worry about it. Okay, so let's look at a couple examples here and then move on to our homework. So I have a current of 10 amps and a resistance of 15 ohms. What's the voltage? So it's 150 volts, because remember, this is going to be my R. This is going to be my I. So V is equal to I times R, or it's equal to 10 times 15, or 150 volts. Okay. Once you try this one on your own, about an individual who is shocked by a house outlet, and then I'll go through it here. So pause, and I'll put the answer up in a second. Volts is V, right? So that's my variable V. 10,000 ohms is resistance, meaning how much current I'm solving for is I. Our current is measured in amps. So to solve for I cover it up. I get V over R. So I plug in V, I plug in R, and divide, and I get my answer here, which is 0.012 amps. So that's enough in order to kill someone, right? Which is why we don't allow people to play with electrical outlets. So now homework, we got 12 questions. A lot of them are general questions. Then the answers are posted on Thursday. You got Wellness Wednesday tomorrow. So if you have any questions, certainly ask me. There'll be more review in the Thursday and Friday folder before the quiz, if that's what you need. All right, guys, love you and miss you. Have a great day.